stepper motor and driver setting for beginner. In this demonstration, I'm using two stepper motor made by Sanyo, Denki, and two driver. One is Stepperonline and the other one is Leadshine. They both are the same except Leadshine had some more features. So settings include micro stepping, driver current setting for the motors, ball screw travel distance, steps per millimeter. So let's start with micro stepping. The typical stepper motor is a 1.8 degree per step, as you see on the nameplate. So which it means the motor shaft move 1.8 degree for every step. So for full revolution 360 degree, the shaft will move 200 steps. So driver has a setting to increase the motor step per revolution. So in this way, the motor step in will smooth out and we will be getting the better cutting results. So for micro stepping, if we want to increase the from 200 to 400 step per revolution, which is micro step 2, the dip switch S5, S6, S7, and S8 are used for setting the 2 microstep. And the 4 microstep will increase to 800 steps per revolution, and 8 microstep will increase the 1600 steps per revolution. So, for example, if we are using the 1600 step per revolution, S to 5, 6, 7, 8 will be set. Must have to set. So 5 is off, 6 off, and 7 and 8 on. So in this way, we'll be getting the 1600 steps per revolution. But the downside is every time we increase the step per revolution, the motor torque will decrease. So there is a calculation, we can calculate the motor torque based on the steps per revolution, but I'm not going to cover that calculation in this video. This is for micro stepping. The other one is motor current setting. So on the driver current table, there's a peak current value, RMS current value, and dip switch setting. To get the proper setting for the motor, we have to look at the instruction. So it has set for a given stepper motor as normal setting the output current to 1.4 times of motor phase current will make it output larger torque, but at the same time cause more heating for both the motor and drive. Therefore, it is suggested to set the output current to no more than 1.2 times the stepper motor phase current. So this 3 amp per phase motor, 3 amp times 1.2 is 3.6 amp peak value. So if you look at the table, the next to 3.6 is 3.8 peak value. So we'll be using the on, off, and off dip switch setting for 3 amp motor. For 2 amp per phase motor, 2 times 1.2 is 2.4. So this is the 2.4 amp peak value. So we'll be using the off, on dip switch setting. So this is how we set proper current for the motor. Next setting is step per millimeter. So to set the steps per millimeter, so which mean the distance the ball screw knob is moving for 1 full revolution. So step per millimeter settings depend on the ball screw we'll be using. So this widely used 1605 ball screw, its diameter is 16 millimeter and the pitch between thread is 5 millimeter. So let's say if we are not using the micro stepping, this motor will move 200 steps per revolution. So every revolution or 200 steps, the ball screw nuts travel 5 millimeter. So for 1 millimeter, 200 steps divided by 5, we'll be getting the 40 steps per millimeter. So if we increase step per revolution to half step, which is 400, we'll be getting the 80 steps per millimeter. So if we increase step per revolution to quarter step, which is 1,600 steps per revolution, the 800 steps per revolution, we'll be getting the 160 steps per millimeter. So if we increase to 8 steps, so which is 1,600 steps per revolution, we'll be getting the 320 steps per millimeter. So this is how we calculate the steps per millimeter value. I hope this video will help you setting for your CNC router. I'm going to stop my video here. Thank you for watching.